What if now in the second case, on the other side, if you see this cart is going upward, not horizontal, in that case our equation will be nothing else. If this is going upward, okay, upward with a velocity of a v meter per second upward. In this case we are analyzing that this b block will go upward with a v sin theta, So if a cart is going upward in which there is a block, okay, we are calculating work done by normal reaction on the block which is inside a cart. So case number second, work done by normal reaction will be F S cos theta. So over here F is nothing but mg sin theta. mg sin theta. We will take this mg sin theta. mg sin theta is bringing this object downward. Okay, downward. Like this, downward. And S is a Vt. S will be same. Vt. Theta would be theta cos 90 minus theta. Cos 90 minus theta. Okay. Look at over here. Let's analyze. Our displacement will be upward h and angle is 90 minus theta. So if our force is in this direction, so our equation will be mg vt sin square theta. So sin theta minus 90 minus theta will be sin theta multiple sin theta will be sin square theta. Okay, will be sin square theta. Cos theta into sin theta is our sin 2 theta. Sin theta multiple sin theta will be sin square theta. mg as it vt. mg is for both cases. mg multiple vt into sin square theta. So just difference is sin 2 theta upon 2. This will be valid for object which is in horizontal. Okay, according to cart. These two equations we will use. According to situation, according to equation. If equation is saying there is a block which is going upward inside other object, then we are going to use mg vt sin square theta for normal reaction. If equation is saying that your object is going in horizontal, which is inside another object, so in that case, what will be your normal reaction? Work done by normal reaction. Then our equation will be mg vt sin 2 theta upon 2. Okay, these two equations we will use. Now let's apply. Equation is a force F vector is equal to 3x square. Over here force is a variable, 3x square I cap minus 4y z cap plus 3k cap is in Newton. Displace a particle from 0, 1, 2 meter to be 1 comma 2 comma 1 meter, then find W. Find W. Look at over here. Already we have a force. Then write over. Right, okay. 3x square I cap minus 4 y j cap plus 3 k cap. This is our force. Clear? It is asking work. Remember, to calculate complete work. If a force is a variable, then you will have to apply calculus. Okay, calculus, or you can say differentiation or integration. If a force is a variable, if a force is not a variable, you don't need to apply calculus. But we are going to apply calculus. Reason is force is variable. Okay, force is variable. So your formula will become integration dw. D came. Reason is D came because of we applied integration. Integration of dw will be integration. Remember over here f is not constant. That's why we will not bring this f outside from integration. So integration f and then our is displacement. So x. Yes. So force is how much? Force is how much? Remember, x is from 0 to 1, from 0 to 1, from 1 to 2, from 2 to 1. This is our limits. Okay, this is our limits. So over here, 3x square, 3x square dx limit. This is 0 to 1, 0 to 1 plus integration 4 y minus, there is a minus 4 y. Don't take z cap. Limit is from 1 to 2. Then again plus. Now integration of 3 limit is from 2 to 1. That is how you will solve. First integration of a first variable, integration of a second variable, integration of a third variable with limits. You know how from where limits will come. Just substitute first of all to integrate it. Okay. So integration of a 3x square will be x cube, 3x square 3 upon 3 upon 3. So x cube. Integration of a 3x square will be our x cube. Limit is 0, 1. Okay. Plus integration of minus 4y will be your how much? Minus 2y. So your minus will come over here. Minus 2y a square. Limit is 1, 2. Then we have one addition more. So integration of 3 will be our 3z. This is constant. Okay. So we know that integration of a constant is going to be x. So 3 is a constant. So over here this will become 3z. Limit is 2, 1. Okay. So first of all we will put a 0 in the place of x. This will become 1 minus. Okay. Remove this minus. Okay. This is 1. 2 2s are 1. So this will become, I think, 2. 2 minus 2 2s are 4. 2, then 2 2s are 4. 8. Am I correct? 2 minus 8 minus 6. Clear? Plus 3z. First of all 2. 3 2s are 6 minus 3 1s are 3. 1 8 and 3. So our answer is, this is also minus. This will be minus. This is a positive. Minus 8, minus 6, minus 6 and minus 3, minus 3, minus 8 is our joule. This is our work. Minus 8. 1. Then we had a positive. Minus 2, minus 8. Not minus 2. Minus 6, this will be as at minus 6. Yeah, till here this is correct. This is correct. 6, oh, it should be minus. Yeah, it should be minus. And this is plus. Yeah, now this is correct. 6 minus 3, 3. 3. Minus 9, 1. Minus 8. Minus 8 joule. Minus 8 joule. Now next question, next concept. Graphical. We are going to observe graphical representation of work done. Okay. Through graph we can observe work done by something. Work done by something. This is a graph. Okay, this is graph. Y is a f and x is a displacement. X is a displacement. Displacement is this much. Y is origin. The area enclosed by this line, by the FS graph, and the displacement axis, this F and S graph will provide the amount of work done by this force, by the force. Okay, so remember, FS graph will provide work done by force, work done by the force, by the force. As we saw, xt graph provides velocity, vt graph provides acceleration. Same over here. ms provides work done. ms graph provides work done. Okay. This is a linear constant. If a force is a constant, remember, if a constant is force, so this will be our complete. Let's say this point is P, Q, R. So work done will be our over here. Work done will be Fs. So Fs is what? Just calculate this as square of rectangle. So according to this graph, area of P, Q, R, O is our area. This area P, Q, R is our work done by the force. According to this graph, okay. Where force is a constant. Now, what if force is a variable? Then force is a variable. Here you will get a curve like this curve. This curve. I am talking about this curve. Okay. So this is our F, S, and O. I'm asking from here x1 to x1 to x, or you can say x initial and x final. From x initial to x final, what will be work done by this force? Now there is a difficulty to calculate area for this curve length. Over here, this was easy to calculate area of PQR, but when it comes to curve, and you feel difficult. Yeah, literally this is difficult. Yeah. So this curve is showing that it's a variable force. Okay? Variable force. If the question is asking just this a small work done, dx, this will be our dx. Just a small work done. Okay. For a small displacement by work done by force dx, the value of work done will be the area of the strip of width dx, this width dx and this height. So your formula will be F is equal to integration of dw from initial to final. Okay. So this will be equal to integration. Over here force is not constant. X initial, X final. F dx. This will be our formula. Integration of dw is equal to integration of f dx. Yes. So your x will come out as x f minus x I. Final minus initial. If the area enclosed above x-axis, work done is positive. Look at over here. If area is upward, okay, upward from the x-axis in this section, then this will be your positive work. Okay, positive. On the other side, if this curve or straight line work done is downward in this section, then your work done will be negative. Clear? Negative. It depends on the axis. Okay. Clear? Application on work. First point. If a force is changing linearly, this linear over here, if a force is changing from F1 to F2 over a displacement S, then work done is, okay, if a force is changing according to displacement, with respect to displacement. Then our work done will be F1 plus F2 upon 2 into S into S. F1 plus F2 upon 2 into S. This equation will be used. Here F1 plus F2 upon 2 is a force and S is a displacement. So F into S is our work done. Force is changing linearly. Okay, linear line you will get. Okay, linear line. This is also linear line and this is also linear. In that case, this F1 and F2, then add and then divide this by 2. You will get, then multiply by displacement. You will get work done. Work done. Okay. What if a force displaces the particle? Let me show you. In this graph, y x, particle initially was over here and it went over here initially. So this will be our R initial. Okay, R position vector initial. So R final will be this R final from A to B. From A to B. And force was in this direction. This is our force. When force was applied like that, then this body displaced A to B. So our initial position vector is R1 and final position vector is over here RF. To calculate the displacement in this case, just R final minus R initial will provide a total displacement between them. Okay. If you are taking reference point to this, then according to this, you see, according to this will be initial and final. According to this will be initial, final. A minus 2. Reference point will matter for displacement, not for force. So to calculate over here, your displacement, it is very easy. RF minus RI. This will be one formula to calculate the displacement when position vector is being provided by the equation. That is why you will find. Okay, R final minus R initial. Okay. So finally you can write W will be equal to F into S. So S is value of S is R final minus R initial. Then your work done will come out. Clear? Now next we have pendulum. Pendulum. Let me erase this part. Pendulum. Work done in pulling. Okay, pulling the bomb. First of all, let me draw a figure. This figure. This is a complete L length of the pendulum, L. And over here, initially pendulum was over here. When force was applied on this pendulum, then it went over here. So what is the displacement between them? You can see this height will be our displacement. So if you take this part, A to OA, so OA, this OA will not be our displacement. Okay, this remaining part will be our displacement. This remaining part will be our displacement. Okay, so AB is our displacement. You can consider this remaining part as a B, a small b. Okay, and this will be L minus B will provide this OA part. So this is our L minus B. Okay, L minus B. So finally you will have to calculate this displacement and force on the tension. And on the tension will be as if this is complete L. L is the length of the string from the center till the end. Okay, so C. Forces in this direction. We applied like this force on the bone. This covered in this covered distance by going in this direction. So over here, try to understand force is a forward, and displacement is a downward. Try to understand. This is our displacement. So this much displacement and multiple force will give us a work done. So if this is theta, you can see it is making an angle, right angle triangle. If this is theta, so of course this is 90 degree. So this will be our 90 minus theta. 90 is minus theta. Now let's read this complete question. Work done in pulling the bob of a mass M. This M of a simple pendulum of length L. This length L through an angle. Angle is also compulsory for this question. An angle to vertical by means of a horizontal force. Force is a horizontal. Okay, force is a horizontal. Question is saying this pendulum is a length. Okay, and when he went from here to till here, he shown a angle. It shown an angle. And force is a horizontal. That is what question is. Our question is to calculate the work done by this phenomenon. You can see. You can see over here cos theta. Cos theta will be our L according to this theta. Base sin theta is P by H. So over here we have B by H. So B is this L minus B upon H. H is L. This is L. If you simplify this, you will get 1 minus B upon L. L is a common. And then if you simplify it further, then your value will be 1 minus cos theta. 1 minus cos theta. Or you can say B upon L will be equal to 1 minus cos theta. So here to calculate to calculate value of B upon A, B upon A will be our 1 minus cos theta. Look, according to this data, B upon H we wrote over here, L minus B upon A. If we simplify it further, then value we will get which will be 1 minus B upon L. Again we are going to simplify it further, then value will come out as a B upon L is equal to 1 minus cos theta. Actually, okay, no problem. Again, B will be equal to L 1 minus cos theta. B will be equal to L into 1 minus cos theta. So just we want this displacement. So to calculate this displacement, we got this equation which is L multiple. This L multiple 1 minus cos theta. How did it come? We have seen over here. So just we started from here and we reached over here to calculate B. So cos theta is equal to L minus B upon L minus B upon this is force component. So this will be cos theta. So cos theta will be equal to L minus B upon L. So L upon L, B upon L. This is our cos theta. 1 minus L upon B, B upon L, B upon L. Now cos theta minus, or you can say cos theta minus 1 is equal to minus B upon L. So 1 minus cos theta is equal to B upon L. We want only B. So 1 minus cos theta into L is equal to B. That is what we brought over here. Okay, that is what we brought, B, value of B. If you want to calculate a displacement, look at over here. B is not B is over here displacement. Okay, so 1 minus cos theta into A. This will provide displacement. Finally you can say work done by gravitational force will be minus mg. It is going from downward to upward. That's why minus is compulsory. Mg is for gravitational force. This is working in a under of gravity. So minus mg, and B is our this mg minus is for direction, and B is a displacement. Clear? B is a displacement. Or you can say minus mc, value of B is how much? L 1 minus cos theta. This is also our work. Clear? This is also our work. Work done by horizontal force. F is W is equal to work done by this horizontal force will be equal to F is equal to FL sin theta. Work done by tension. Remember over here, there are some points. This concept is providing some points. Work done by horizontal force F will be F is W will be equal to FL sin theta. Look at our F is the horizontal and L is a vertical. L is a vertical. and sine theta is 4 1 minus cos theta, 1 minus cos theta. Work done by a spring, work done by tension T in the string will be 0, inside the string. Work done by tension, work done by the tension in the string will be 0, This is fact. Work done by gravitational force. Okay, work done by gravitational force in pulling a rod. If a string is pulling a rod, okay, a uniform rod of mass m and length l, length of the rod is l, through an angle theta is given by. In that case, if there is a rod, let's say this is a rod from here to here, rod, okay, and this string is pulling this rod. So then in that case our work done will be minus mc. It is going upward. So minus mc L upon 2. This is a half. So half rod will go over here. Half rod. So length of the rod will be half L upon 2. And theta is 1 minus cos theta. 1 minus cos theta. Clear? Just over here length will become half. Only length will become half. That's it. Now next topic. Next topic. This is wall and one ground. There is a ladder. This ladder half will be our L upon 2. If the length of the ladder is L, then this half will be L upon 2. This angle is theta. Listen to me. A ladder, this line is a ladder. A ladder of mass m and length L resting on a level floor is lifted. This resting part. Ladder is placed in such that, like this. Okay, so one point is on the horizontal and one point is on the vertical of the wall. Okay, so held against a wall at an angle theta with the floor. Okay, work done by gravitational force. It is asking work done by gravitational force will be what? There is a ladder. Try to understand. The question is saying there is a ladder whose two end points. The first end point is with contact of ground, and the second point is with contact of wall, with contact of surface of the wall. Clear? And this is a point where half of the rod is becoming L upon 2, and L is the complete length of the rod. L is the complete length of the rod. Question is just asking what work done by gravitational force for this, what will be? What will be? When it comes to gravitational force, you know that mc is a compulsory. mc is a compulsory. Remember, when it comes to work done by gravitational force, so remember this is our non-conservative force. Means it does not depend on path. Okay, it will take always a vertical displacement, not horizontal displacement. Okay, this gravitational force, work done by gravitational force, this will take a vertical displacement. Remember, vertical displacement. It not care about, does not care about horizontal displacement. Okay, so always take a displacement which is a vertical. Okay, which is a vertical. So over here mz will be our mzh. H is a displacement and mz is a force. Clear? Minus is for direction. If length, height is L upon 2. If height is L upon 2, then you can replace this h by L upon 2 minus g into L upon 2 and sine theta. This will be your value. If you want to replace this equation by this, you can replace. Just find h, your h. Okay, h. How did this sine theta came? Remember, this block will come downward. Let's say there is a block. So of course block will come like this. So over here we see that this is nothing but mg sine theta. So that is what this is sine theta. mg sine theta. And h is our L upon 2. This will be our L upon 2. Okay, so mg sine theta minus is for direction, and L upon 2 is a length. Now next, this is there is a table. Okay, this is table. There is a table. A chain is a hanging. A chain is a hanging like this. This is a small length, which is L upon 2a, and this complete length, which is L upon n, and this is a CG. Try to understand. This is figure where we have a chain and a table. Chain is placed on table, and one part of the chain is hanging like this. So this hanging complete part of the chain is L upon h. This is a length, you can say L upon h, and this is a small part of the hanging chain is L upon 2n. Okay, L upon 2n. Let me get a particle of a mass m. M is suspended vertically using mass of a rope of negligible. If the rope is used to lift the particle vertically up, here you can see this is vertically, vertically up with uniform acceleration. And acceleration, if we use a rope, if we use rope to lift this vertically, this chain vertically up by applying acceleration. Try to understand. I am going to use a rope to lift this chain which is hanging by some acceleration. Work done by tension in the rope will be what? In the rope will be what? So remember, work done by tension in the rope, and here rope is negligible. Mass of a rope is negligible. Okay, rope is not negligible. So in that case, our work will be equal to mc plus a into h. So h is over here height. H is over here height. mg plus ma into h. mg plus ma into h. This is our equation. If a block is lowered with acceleration a, then just sign will be replaced by negative. Okay, if block is going downward, in that case, just we will replace this sign minus m z minus a. That's it. Into h. H is a height. mg is a gravitational force which is a downward, and ma is a mass with acceleration. Ma is a force. So net external force into h. So mg minus ma. Okay. A uniform chain of mass m and length l is kept on a smooth horizontal table such that its length is hanging. Only one part of its length is hanging over the edge of the table, as we can see over here. It is saying a uniform chain, okay, chain of mass m and length l. This complete chain, length of this complete chain is l. So this part is l upon h. So this will be a small part which is l upon 2a. 2a is kept on the smooth table. Length is hanging over the edge of a table. Value of work done by the pulling force. So it is asking value of work done by the pulling force to bring the hanging part onto the table is what? Value of work done by the pulling force. We will, let's say you are using a rope just to bring this hanging part onto the table. So how much will be work done? How much will be work done? So of course upward, force is upward, and this will be our displacement. So displacement will be, I think displacement will be L upon H, and pulling force will be our force. So W will be equal to M upon N, this nth part, into GH. Into GH. Not over here. Remember, in this case, work done on the two blocks by tension. Work done by tension on two blocks Okay, on the two blocks will be always zero. Will be always zero. Remember, where it comes to tension, work done by tension. Okay, remember. So this is our zero work done. Now let me write question. Question is a body is displaced from 2I cap plus 4j cap minus 6k cap to RE 6I cap minus 4j cap plus 2k cap under a constant force. Two I cap plus 3j cap minus k cap. Find the work done. Try to understand. What is question saying? Question is saying there is a body which are displaced. A body is displaced from this position vector till this position vector. Try to understand carefully. Initially, this was over here. Whose position vector is something like this. 2I cap plus 4j cap minus 6k cap. Then it went over here. Whose RB position vector is 6I cap minus 4j cap plus 2k cap. This is our position vector of final location of the particle of the body. We know how to calculate displacement when position vectors are given. This final mention will be position displacement. Force is given. Okay, force is given which is a constant. If a force is not providing ax, y, z, then you just understand yes, force is a constant. If a force is providing ax, y, z, it means force is a variable. Okay, you can write force, constant force 2I cap plus 3j cap minus k cap. Got it? Displacement would be nothing but RB minus RA. RB is how much? RB is, look at over here. RB is 6 minus 2, 4I cap, 4 minus 4. Hold on. 4 minus 4 will be 0. 4 minus 4 will be 0. I cap, and then we have minus 4, and then minus 4 will be minus 8 j cap. Look at over here. Plus 2 plus 6 will be our minus plus 8 plus 8 cap. Okay, this is our position vector. Work done by the force will be our F into S. So F is 2I cap plus 3j cap minus k cap. Clear? S is a 4I cap minus 8j cap plus 8k cap. Okay, got it. So look at over. When it comes to a scalar product, you know that just multiple with the same factor. 2 4 is 8. Okay. Plus minus minus. 8 3 is 24. J not j. Minus plus minus. So 8 1 is 8. 8 32. 2 then 6 24 minus 24. Minus 24 is a joule. This is our answer. Minus 24 units or joule. Now next question. Question was very simple. Just it was providing force which was constant and coordinates, position vector you can say, position vector. All these were values and just we calculated work done. First of all, we saw that force is this much and we calculated a displacement just by using final Manson initial. Then we got this much displacement, then we multiplied this force vector by displacement vector, then we got W. Clear? W. Now let me erase this part so that we can move towards the question. Towards the question. Next question is a force F is equal to 2x I cap plus 2j cap plus 3z square k cap. N is acting. Just you have to calculate work done. Okay, nothing else. Work, nothing else. Try to understand. Is your work variable or constant? Is your work variable or constant? You would say not work but force. Force is a variable. Am I correct? For variable, we use calculus. We apply calculus. Remember. So your work will be integration of look at over here. Your work will be integration of this first term 2x and limit would be 1 3 1 3. Okay, then plus just add all terms add. Okay, integration of a second term 2 and over here we have 2 from 2 to 6 to 6. Then add second third term 3z square. So integration of 3z square, limits are 3 to 1. That is how we do. when it comes to variable force. Okay, when it comes to variable force. How to identify that force is a variable or constant? If like this x, y, z is common, then make sure that this is our variable force. Variable force. So integration of 2x will become 2x square upon 2 means x square. X square. Am I correct? Limits are 1, 3 plus integration of 2 would be 2y. 2y. Limits are 2, 6. Integration of 3z square again 2, 3. 3. So this will become z cube and limits are 3, 1. Am I correct? Yeah. Yeah, till here you are correct. So finally our answer should be minus 10z, nothing else, minus 10z. First put 1 in the place of x. So 1 minus 3 3 is a 9. 1 minus 3 3 is a 9 plus 2 2 is a 4. 4 minus 6 2 is a 12. Okay, plus 3 3 3 is a 9, 9 3 is a 27 minus 1. Now let's see, minus 8 plus 26 0. So minus 16 plus 26. Answer is plus 10. Answer is plus 10. Plus 10. Okay. What if we take like this 9 minus 1 plus 12 minus 4 plus 1 minus 27, then 8 again 8 minus 26, 8 8 is 16 minus 26, this will become 10 but minus 10. Yeah, so from upper to limit, this is your wrong method. Okay, this is your wrong method, this is your correct method. That is our right answer will come. So this is our work done, which is a unit minus 10 units. Final minus initial. Final limits minus initial limit.